BTC GO version 0.6.1. Yeah, my friends, this version here is something else. It has 3 modes. The sequential start, we already know if you want to check out the previous videos. And the random mode, which people really like, right? That random mode activates your luck and searches anywhere to try in any luckier way to find that wallet. Today we're going to see how amazing that mode is. Thanks to Rafinha Bortan, who made our pull request over on GitHub. Attention, you cannot use this code to in any way search for lost wallets, wallets that belong to someone, We are exclusively searching for puzzle wallets. These are wallets that were created in 2015 with the intention of you finding them. So this is the pull request from our dear Raptor. I hope I'm pronouncing the name correctly, which adds the database here so we can do this verification. So it has mode 3, which is the new mode that can use the database so you don't search in the same place, and then you can choose whether to use it or not. Here we have a very simple implementation of the new database. It implements the insert function and the exist function, meaning every time I search, I will do an insert to know that I've already searched. And before searching, I'll check if it exists to see if it's already there, so I don't search again. And here we have a new variable, which is the number of records in random that we can choose when we're using the program, okay? And then it checks the modes here, because one mode uses the database and the other one doesn't. And if I'm in database mode, it checks if my control is greater than the number of records I've chosen. On the next key, it goes back to doing a random search. So it will add here the key that I've already found. Okay? So let's run it to see how it works. Let's go. My code is already compiled, okay? If not, you compile yours. I'm going to run BTC GO. It's going to show me here that I'm using version 0.61. I'm on the correct version. How many CPUs am I going to use? 20, which is my total number of CPUs. My wallet is 66, which is the wallet I want to find. And now I'm going to choose mode 3, random. It's going to ask me, do you want to use the database or not? I'm going to choose option 1, which means it will use the database. It will save the keys I've already searched for, and Pacta won't search again. And here, the number of records for each RAM, no, I'm going to set the default that it suggests, which is 10,000, okay? That number there will vary according to the disk usage it will have on your computer, right? Because if you set it too low and it keeps saving any key, it will take up all the disk space on your computer, so it's not efficient. It's good to save a key, and then you already know that you've searched sequentially, and then you save another one. You see? So it's searching for 80,000 keys per second, a certain drop in performance, probably because of this database check, or maybe because I set a small number. Let's stop here for a second. I'm going to try putting a bigger number to see if that improves the performance. How many CPUs do I want to use? 20, wallet 76, mode 3. I'm going to set it again with DB because I want to run a test. Instead of 10,000, I'm going to set it to 200,000 to see if that makes any difference in performance. If I'm correct, we're going to see a different performance of 80,000 keys per second. No. It continues with 70,000 keys per second. Something in this code is bottlenecking the performance because this performance can reach much higher. We've already seen that it's reaching almost 1 million keys per second. If we go back here to our Visual Studio, we'll see that it created new folders here. Inside the DB, there are folders that weren't in Git. Each folder here is a wallet, A24, A30, by A66, and inside it saves the database, you see? Each little file here is a database file. That's why I told you to be careful with these parameters, because otherwise you could fill up the entire disk, okay? Pay attention. Don't start running things without knowing what you're doing. Now I'm going to run it in normal mode because I got worried about the performance. I'm also going to choose wallet 66, but I'm going to set it to mode 1 from the start, which I know is impossible. Everyone has already searched at the beginning. The wallet isn't there, but I just want to see its performance. And now it's running at 757,000 keys per second. So something there must be blocking that performance. I'm going to try to research and find out. If not, I'll talk to Rapte, but to see if he can figure out what's going on with the random code. I have the impression that what's happening is that the database is decreasing the performance. All right, I'm going to set wallet 66 again. I'll choose the random mode, and this time I'm going to run it without a database. If I'm correct, now the performance will be similar to the sequential one, around 700,000 keys per second. Let's see. Now it's going to show up. You see, that's exactly what's happening. Database operations are very heavy, especially when you're searching the database to see if the key is already there or not, constantly inserting the key into the database. That's why I personally prefer to run without a database. The range is so vast that statistically, the chance of me searching for a place I've already searched is really small. And even if I do search, it's not the end of the world, okay? It's going to search in the same place, then it's going to look for another, it's going to look for another. The chance of me searching many times in the same place is almost zero. But there are a lot of people who ask for this database change. And again, thanks to Raptor, if you can make this change to the database and get better performance, wonderful. But for now, I'm going to use it without a database, okay? Because I don't think it's worth it. The performance is much higher, and the chance of me searching in the same place is very small. Another cool thing, especially for those contributing, is the organization of the code. You can see that now the code is much more organized. Instead of having a huge main file, the main file is now tiny. And you have everything nicely separated here. The app, the console, right? To ask the questions about the modes. The database that we just saw, here we have the worker, just the worker's function. We have here inside Teals, for example, base 58, which is just the file for base 58. Bitcoin, all the functions of Bitcoin, generate Wi-Fi. Generate hash160 checksum, everything is nicely separated. So if you want to make a change, it becomes really easy and also helps avoid conflicts. When we're merging our pull requests. Look here, there's a file just for the title. See how cool that is? It automatically grabs the version. Thanks to that, all the GitHub contributors who helped us reach this level of code. Now I want to show you something interesting, okay? I haven't had time to test it yet, but if anyone can test it and let me know the results, please. Here in the worker is where the magic happens, you see? We have here, look, we receive a private key, which we keep incrementing all the time, right? To try various ones. First, we convert it to the address using this function. Then we talk to the wallet using this function. Then we compare. If the wallet is the same as the wallet we're looking for, congratulations, you found a wallet full of Bitcoins. Now what I want to show you is this function here, hash160 to address. If we go here to Bitcoin Go, all it does is append 00 to my address. Then it does a checksum. Then it appends the version and the checksum, and then it does the encoding. The encode is our base 58. It's our base 58 encode. What if I could skip this step here? For example, I can take the wallet, I can do a decode, and then I skip this step here. And instead of comparing with the encoded result, I just compare with what I already have. Decoded, and that way I save this encoding operation here, which is this operation. That's inside my tools, inside my base, right? Inside my base, I have the encode, and I also have the decode. I don't know how long overcoming it takes, but maybe we can save time and achieve even better performance. So, what do you think about this test? If someone tries it and finds out the results, let me know, and then I'll implement it in the next version of Bitcoin Gold. Or you can do the peer request, even better. If you like this video, give it a smart like, subscribe, join our Facebook group, our Discord group, and use all your luck to find those Bitcoins that are out there. See you next time, guys.